So you brought us some really fascinating material today, all centered on this incredible Hubble image. We're looking at a galaxy, NGC 3507, right? And its surroundings.
That's right. It's just a perfect example, really, of what tools like the Hubble Space Telescope can show us. Things we just couldn't see otherwise, these amazing structures, and, well, across vast distances.
Absolutely. And that's our mission for this deep dive, isn't it? To kind of unpack what's hiding in this image, what it tells us about, the universe and maybe even our own place in it.
Yeah, exactly.
So let's dive right in. The main subject, the star of the show in that picture, is NGC 3511 itself.
Yeah, it's beautiful. A really dazzling big cosmic swirl. It's what we call a spiral galaxy, a classic example.
And location-wise?
About 46 million light years away from us, so relatively close on a cosmic scale, located in the constellation Leo.
Okay, and you mentioned it's a spiral galaxy. The sources point out it's a barred spiral. What does that actually mean visually?
Right, a barred spiral.
Yeah.
And because we're seeing it face on in this image, it's really clear. You see, the arms, the spiral arms, they don't just swirl out directly from the very center. Instead, there's this bright, prominent bar structure made of stars going right through the middle. The arms seem to stretch out from the ends of that bar.
Gotcha. And that face-on view is pretty important, you said.
Absolutely key.
Yeah.
Because you see, NGC 3507, while it looks amazing there, it's actually not alone. It's part of a pair.
A galactic duo.
Exactly.
Yeah.
Its companion galaxy is called NGC 32501.
Okay, NGC 3501. Now, it's not really in this main picture of 3507, is it?
No, it's just outside this particular frame.
Yeah.
But when you look at images of NGC 3501, well, it's a whole different story.
How so different?
Completely different looking. It's actually a perfect illustration of how much perspective matters in astronomy.
Okay.
So NGC 3507, we see it face on. Right, like looking down onto a spinning pinwheel.
Right, the classic spiral look.
But NGC 3501, its partner, happens to be tilted completely edge on from our point of view.
Edge on, so we're seeing it from the side.
Exactly. So instead of that grand swirl, it just looks like this sleek, silvery streak across the sky. Really elongated, very narrow.
Wow. So hang on. You have two spiral galaxies, neighbors in space, possibly quite similar in actual shape.
Potentially, yeah.
But just because we see one face on and the other side on, one looks like this majestic swirl and the other looks like, what, a sliver?
Pretty much. A cosmic sliver, yeah. It's not just a neat visual trick, though. It's fundamental.
How we see things dictates what we see.
Precisely. The apparent shape, the features we can make out,
Yeah.
it all depends massively on our line of sight. What looks like maybe a boring streak could actually be a magnificent spiral, just turned sideways to us.
And this idea of perspective and distance, too, it plays out even within that single Hubble image of NGC 3507, right? Not just with its partner.
Absolutely. That image is packed with information about distance. You look at NGC 3507 itself, relatively nearby. Remember, tens of millions of light years.
And we see loads of details.
Loads. You can make out the spiral arms clearly, the dust lanes within them, bright clumps, which are star clusters. Real structure.
Okay. But scattered around it in the background.
Ah, yes. Look closely at those much fainter, smaller smudges of light in the background.
Those are other galaxies, too.
They are. But they are much, much farther away. We're talking potentially billions of light years for some of them.
Billions. Wow. And they look different because they're so far.
They do. They appear, well, smaller, obviously, much less detailed, often sort of fuzzy, maybe with an orange or yellowish color.
And their shapes.
Can be anything from little roundish blobs, almost like faint stars, to slightly elongated streaks. Sometimes, if you're lucky and the orientation is just right, you might see a hint of spiral structure, but usually not much detail.
And astronomers actually study these really distant ones.
Oh, yeah. That's how we learn about the early universe. Their light has traveled for so long. We use instruments called spectrographs to split their light into its component colors.
Like a rainbow.
Sort of, yeah. Analyzing that spectrum tells us about their composition, their distance, how fast they're moving, all sorts of things about what galaxies were like billions of years ago.
So in one frame, we have NGC 3507, relatively close, and these ancient galaxies incredibly far. But you mentioned there's something else providing an even starker contrast.
Right. There's that really bright object in the image, the one with 4 prominent spikes coming off it.
Yeah, looks very different from the fuzzy galaxies. Looks like a star.
It is a star. And those spikes, they're not real, they're artifacts. They happen because of the way the telescope's internal structure interacts with bright, concentrated light. But they immediately tell you it's something different.
Different how?
Because it's not millions or billions of light years away. That star is right here in our own backyard, cosmically speaking. It's inside our own Milky Way galaxy.
Inside the Milky Way. So how far is it then?
The sources say it's only about 436 light years away.
436 light years, compared to 46 million for NGC 3507 and potentially billions for the background ones.
Exactly. Just think about that range in one single picture. A star practically next door, a nearby galaxy millions of light years off, and then hints of the ancient universe billions of light years away.
That's mind-boggling, the depth in one snapshot.
It really is, and it shows the power of the instrument that took the picture. Which brings us, of course, to Hubble.
The Hubble Space Telescope, an icon.
Truly transformative. It was launched way back in 1990, a joint project between NASA and the European Space Agency, ESA.
And its big advantage is being in space, right? Above the atmosphere.
That's the key. It orbits Earth about, 340 miles up, something like that. Being above the blurring effects of our atmosphere means the images are incredibly sharp.
Sharper than anything we could get from the ground, at least back then. And it can see types of light the atmosphere blocks.
Precisely. Things like ultraviolet light. It's equipped with these incredibly powerful cameras, but also spectrographs, like we mentioned, for analyzing the light.
And its contribution list is just huge.
Oh, absolutely legendary. It completely changed our understanding of, pretty much everything. Galaxies, how they form and evolve, nebula, where stars are born, black holes.
Doesn't it help figure out how fast the universe is expanding?
Crucially involved, yes. Measuring the Hubble constant. And it provided some of the key evidence that led to the discovery of dark energy, this mysterious force accelerating the expansion.
Plus, the images themselves, they're just breathtaking. They've inspired so many people.
Definitely. Beyond the science, the sheer visual impact is undeniable. But, keeping an instrument like that working up there,
yeah,
that's a major challenge.
Right, you can't just send a technician up easily. The sources mentioned the servicing missions.
Yeah, like Servicing Mission 4, SM4 back in 2009. The crew of the Space Shuttle Atlantis went up.
And did repairs and upgrades.
5 spacewalks. Really complex work, installing new instruments, fixing existing ones. It basically gave Hubble a new lease on life, significantly boosting its capabilities.
Which is why it's still doing cutting-edge science today, even with newer telescopes coming online.
Exactly. It remains a cornerstone. Its unique capabilities, especially in certain wavelengths of light, it's still absolutely vital. It continues to give us these incredible views and data.
So thinking back over everything, we've got this stunning galaxy, NGC 3507.
Beautiful, barred spiral seen face on.
Then its companion, NGC 3501, looking totally different just because we see it edge on.
That crucial lesson about perspective.
And then the sheer scale Hubble captures from a nearby star in our own galaxy, out millions of light years, out billions of light years, all in one go.
It really underscores both the complexity and the vastness of the universe, and also, human ingenuity in building tools to actually observe it.
It really does. Which leads to maybe a final thought, something for you, the listener, to ponder.
Okay.
If just changing our viewpoint, our angle, can make a grand spiral galaxy look like an indistinct streak, what else might we be missing? What fundamental truths about the cosmos might be hidden from us just because of the particular perspective we happen to have right now?